This is the Amp Hour Podcast, recorded September 29th, 2014. Episode 218, with guest Eric Van Wyk, Meiotic, Mountenance, Mooshimeter.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
And I'm Eric Van Wyk of Mooshimeter Engineering.
Who nailed the intro. Excellent work,
mushy.
Eric.
Mushy.
Thank you for joining our humble show.
Oh, thank you so much for having me.
And if people are wondering what my voice is, yes, I've got something. So I'm going to sound worse than I ordinarily do. But Eric sounds wonderful. They're from, where are you hailing from?
I'm just outside of Boston right now in Needham, Massachusetts at the Olin College of Engineering.
How big is the Olin College of Engineering? I've never heard of it.
I think we're just north of 300 students now, all told.
Okay.
And listeners may remember two guests in the past have been from Olin.
I don't remember details like that.
It's okay. But yeah, Kent Lundberg was a professor there, and Ian Danaher was a student there. And I couldn't remember if anyone else was there.
There you go.
Ian was a student in my class.
Yeah, so Eric is both, actually. That's pretty crazy. So they asked you back, right? This is like a student becomes the master kind of thing, huh?
I think they were trying to fill in the gaps in my knowledge, but it's good to be back.
Well, is it just an engineering school? Or is it a...
Yeah. Olin offers 3 degree programs, electrical engineering, mechanical engineering, and engineering. And the third one's kind of a choose your own adventure, as long as your adventure is in engineering.
See, that's fascinating. We don't have an engineering-only school here in this country. Yeah, that's just foreign to me.
What, like engineering's always something else? Basically,
it's always part of it's always part of a uni. It's always part of a big university who does 10 million other things, you know?
Yeah, right. Gotcha.
Right, but this is just set up as an engineering college.
I like to view it as the students at Olin are professional guinea pigs for engineering education. And so the main research output of the university is attempts at figuring out new ways to educate engineers.
Interesting.
So, does it work?
We'll see. I had a lot of fun, but no, I think it's working. I hope it's working.
Yeah, I wonder about that too, like how it changes the dynamics of, like class sizes and stuff like that. And, there's positive and negatives about that, having smaller classes, being, tighter knit. Like I hardly knew anyone in my engineering classes even after 4 years. And
yeah, totally.
Seems like when you only got 300 at the whole school, it's kind of a little more.
Yeah, it's much.
And I was part of the second class admitted, so that meant that when I showed up as a freshman, there were no juniors or seniors, so it was 150 total.
Right.
100% fewer wedgies.
Yes.
I just it's like a chicken and egg thing. I mean, how do you start an engineering school and then get students to agree to come to it when it has no reputation at all? How do you make a choice? Oh, I'm going to go there instead of a real college, in quote marks, right? One that's got a real ivory tower, right?
I think you just have to drink the Kool-Aid. When I made the decision, it was after I met the faculty, and they were very clearly passionate about what they were doing. And I remember the moment of thinking, well, this will be an interesting adventure, and let's see what happens. And I'm glad I did.
So who founded this? Where did the faculty come from? Do they just magically appear, this faculty, or
A good portion of them were pulled from the local engineering colleges. So we got a few from MIT, and then just like-minded people that were interested in researching how other people learn.
Oh, okay, right. So it was actually set up, like you weren't joking, it is set up as a school that learns how to learn.
Yes.
I guess.
Messes with its students is the answer.
It sounds very war games to me. The machine actually learns how to learn. Whopper. You know? Sorry, that just popped into my head.
So Eric, and you teach so we've talked about this a little bit offline before, but like you teach a non-standard. Well, what's the class now called?
Sure. I think you're referring to the seminar that I'm teaching, which is affectionately referred to as Danger, High Voltage.
Yes, that's the one. And what is that?
It's a 1-credit seminar, so I have about an hour of their time a week worth of lecture and 2 hours outside of class. And what we're trying to do is work through how you make a product that is safe in the hands of consumers or in the hands of patients, how you go through the regulatory process, what it means to do a HiPot test versus a ESD test, why you would want to ground, all of the stuff necessary to make sure that your device is safe.
Yeah,
Wow.
which is awesome.
We never had anything like that.
Yeah,
those classes just didn't
close.
exist. Yeah, not even close.
Yeah, one of the experiments they're running right now is alumni are allowed to come in and teach these 1-credit seminars on basically whatever they think might be interesting to the students.
Wow.
Since my background my background immediately after graduation was in medical device development, and now I've been working on this Mooshimeter, I've been doing a lot of regulatory compliance and thought they might be interested in it.
Yeah, what was the one? You had a seminar before this one, too. That's the one actually I was thinking of.
The power supplies.
Yeah, right. So what was that one?
Well, every circuit board that you make has a couple power supplies on it, just about. And I knew nothing about it, about designing those coming out of college. So I figured it would just go through what's a linear regulator, what's a voltage reference, what's a buck regulator, how do you spec that, how do you talk to a vendor, how do you figure out your supply chain for those types of decisions.
Yeah, that's awesome. That's, I've only ever heard, I'm sure there's other classes like this, but I have limited. But I know, so Larry Sears, former guest of the show as well, he does a class of case here in Cleveland, which is like really hands-on, really, covers a lot of that other stuff as well. And then Kent, also, who Olin professor at one point, he did stuff with like like reverse engineering stomp boxes or something like that.
Oh yeah, he did some great stuff in, I think it's electrical engineering prototyping. I think that was the title of his class.
Yeah, right. Yep.
See, I find that fascinating because you've done, right? You did your degree and you just said, yeah, I came out not knowing how to, build a simple power supply into an actual product, like a little DC to DC converter or a linear regulator or whatever. And that's, that goes to show what we've been talking about for years, that, engineering is so broad. And you have to learn so much that you just, you don't end up learning all of the basic things you think you should or that are needed. Right.
Well, and they can go deep too. I mean, like you can go as deep as you want on power supply stuff, like DC to DC converters. But But yeah, sometimes you don't even touch that stuff until you need to. So that's great. That's great. You expose the students to that. That's really cool. And I remember too, you said something about when you were designing that curriculum, something with like. It was something like a simple like LM317, but they had to design it themselves, like just a simple voltage regulator or something like that.
Yeah, one of my favorite things to do for that class was to describe a problem and then only allow them to use chips they could find in the stock room.
Nice.
And so I remember one of them was to make linear regulators out of whatever was on hand. And some of the students used a Zener diode as their voltage reference, which is fine for that type of task. And some of them just stacked up normal diodes. And then we measured the performance of these cheapo, crappy linear regulators that they made on breadboards. And so I brought in a hot air gun and would just blast air at their device and say, okay, what is your temperature coefficient? And it was really fun to see that the Zener diodes and the regular diodes would have opposite signs in their coefficients, and that blew their minds.
Yeah, that's great. I mean, that's great hands-on stuff. I like that a lot. So you mentioned the medical stuff as well. Why don't you tell us? Why don't you kind of work us backwards then, or go from your graduation forwards? I guess.
After graduation, I joined DECA Research and Development, which is in Manchester, New Hampshire, and most of what I did there was medical device development.
People might know that from Dean. That's Dean Kamen's company.
Yes, that's Dean Kamen.
Segway and yada yada yada. The Luke and stuff like that.
So I had become involved in that because I was very much into FIRST Robotics, which is the high school robotics competition. My senior thesis project was to re-architect the control system for that competition. And then when that proposal was accepted with huge, heavy modifications, I joined DECA so that I could continue working on it. But my day job was to design medical devices.
Right. And how much of your day was spent regulatory and paperwork and other stuff, and how much was actually spent designing?
So my particular role was more, so I started out in more design, but it was, a lot of it is designed for regulatory. So not the testing process, but the figuring out how you can design something to eventually pass it.
Yep.
Which really appealed to the OCD in me. And making spreadsheets that would indicate how many patient errors would occur given these parameters, and always striving to make that as close to zero as possible.
Spreadsheets,
pivot
data,
tables, VLOOKUPs, yay.
It is
I have a feeling I'm not the coolest guest you've had before, but it's really satisfying.
That's good.
Yeah.
Data's fun.
It's nice. It's nice when you change like one cell and like the whole thing just goes zoop and just the whole thing updates. That's great. I love that kind of stuff.
Oh goodness.
So when you say designed for regulatory though, so like what is this mostly like FDA? I don't know much. Actually, Alicia and Chris on the Embedded podcast, they went over a bunch of a bunch of the regulatory stuff in a couple episodes ago, and I really didn't know much about the ones that are out there. Which is this just like generic FDA type approval stuff? So
the FDA is what took more time out of my schedule. We were working primarily with Class 2 medical devices, which are fail-safe devices, which means that any one component in your circuit can be faulted in whatever way, and you need to continue to. You don't have to continue delivering care to the patient, but you need to make sure that you stop delivering care in a safe manner.
Well, I thought every medical device would be at least that class.
Sure, so wrong? Class 1 would be like a Band-Aid, and if the Band-Aid falls off, that's fine.
Right.
Class 2 is that it needs to fail in a safe manner, and Class 3 means that it needs to operate through a failure mode.
Got it. Right.
And several of the products that the company was working on were Class 3. But I was not specifically working on those.
Class 3, I can imagine, would be extremely difficult.
Yes.
Because how many failure modes can you think of and cater for? I mean, it can't be an infinite number.
Right, and it's interesting to go through your design and find orthogonalities in it and start to reduce it so that you can begin to approach it, because an exhaustive approach will just take infinite time, as you said.
Yeah. Goodness.
It's also fun because it means that for just about everything you do, you have to come up with two separate ways to do it. So if you have an argument with another engineer, you can say, okay, you can be primary and I'll be backup.
What does that mean?
So if you have something in the circuit that performs a function, it needs to have a backup for that. And they need to be different from each other. Which means that if you design it one way and I design it another, maybe both of our designs can get into the final product.
Oh, that's kind of fun. Sharing means caring.
Yeah, but then you've got to have a mechanism in place to switch over from one to the other.
Yeah,
I mean, that alone requires a separate designer just to handle that aspect, right?
Mm-hmm.
Yeah, fail over and all that crap. We had that in industrial in a couple places, but it was always more expensive.
And
which I'm sure
one of the
this
common
stuff
ways to do that is to have both halves always delivering care, so that if one fails, the other can continue.
With half care,
yep.
But some care.
Yeah.
You are now half this healthy.
Hey, would you be able to give an example of that is like something that drives a pump. Would you have two separate pumps with two separate pipes, and then you'd get at least half the fluid going through, or something? How would?
So maybe you have a motor that's bifilar wound, or you have two motors that are driving the same shaft, and then everything that powers that motor would be an independent circuit.
Right, and then the motor, if one motor failed, then that would be like a slip thing, and the other motor could so it wouldn't lock up the shaft.
Exactly.
And then the other one would got it. Okay, interesting.
It's like your mom's cruise ship, Dave. How it was going with one motor for a while, and then it just stopped.
Right, then it just died. Oh goodness.
So you said you couldn't talk about all the products you worked on there, Eric. But what are you going to talk about? Any of the products that you were there, like the first stuff, or
sure? I was very fortunate to be able to work with the team that was developing the new FIRST robotics control system when it switched over to the Compact Rio. So the team was people at DECA, people at WPI, BAE, Texas Instruments, or at that point Luminary Micro, and National Instruments. And of course people at FIRST itself.
And Compact Rio is an NI standard, right? Or is that broader?
Yes, it's an NI standard.
Okay. Yeah, I think I've seen that before. It's like kind of industrial control-y kind of, and then they have the GUI, like the LabVIEW type GUI, right?
Exactly.
That's rather clever. How to sell more product. Get it specified as the standard platform in FIRST Robotics.
That's right.
Well, all of those Compact Rios were given away for free, so it wasn't a very profitable move.
Oh yeah, no.
You want to bet?
It's backloaded, Eric.
You
want to
bet?
Every kid who goes to Olin, and then they go to whatever company, and they're I'm used to using Rio. Yes, this is good. It's very smart. I mean, there's nothing against it.
No, it's just very clever.
Yeah. So that's cool. So like the controls. So like the so is there like a standard compute module that they give every team? Is that the idea?
Yeah, so the Compact Rio runs all the user code in one processor, and then there's an FPGA in the backplane that handles safety stuff and everything that the students don't need to be worrying about. And then that plugs into a set of hardware. My task was to design the non-COTS hardware to provide an easier interface for the students, so power distribution or digital breakout, things like that. So they all get a standard electronics kit and then a couple standard mechanical components, and they can go from there.
But does that take all the differences out of the robots, or does or does it, or is it important to have a sort of a fixed playing field at the embedded processing level?
So is your question electrical or mechanical in nature?
I guess it's both, because I thought like it was like a free-for-all, like you had, your specs had to be, okay, your robot has to fit with inside a cube, or it has to be X dimensions, and that was it, and the rest was left up to you of how you actually did it.
Sure. Kind of so I have two different answers for the two different fields, and for electrical, it does level the playing field in a large manner, but I don't see that as a bad thing.
Right. Okay.
Because I don't believe that it levels it down. I believe that it levels it up. And there is always the ability for teams to add their own electronics. And in the rules, there are specifications to say, basically, you can't put your electronics in the path of the safety control system.
That's good.
If you want to put a camera on there and strap your own processing board on there, and then send the information through the safety system, then you can do that.
Oh, that's pretty cool.
Right.
Teams will make boards that pick up sensors, and that's always fun to watch. In the mechanical realm of that, there's much less of a level playing field. There is a Kitbot chassis that you can use, and not very many teams do. So you see an extremely wide range of designs. And my favorite thing to do is wander around and look at all the different ways that they make their robots move.
Right.
4 wheels, 6 wheels dropped. Do they have Omni wheels? Are they using Mechanism? Are they using Crab, Twitch, Octonum? It's really neat to see all these different things these people have come up with.
Dave, do you know what he's talking about, right? I have had 6 wheels. I was like, okay, yeah, sure.
I think I was lost at Crab or something. I don't know.
Sure, but they've designed drive systems that can drive sideways.
Right, yeah.
Wow.
Yeah. Very
and
cool.
then there's probably 6 or 7 different ways that they can do that. And each year, a team or two will come up with a new way that might not become canon.
Got it.
So you go to the competitions every year still and everything?
Yeah, I was a robot inspector for a couple of years.
Robot inspector on the business card. Robot inspector.
That's great.
Yeah, it's a real blast.
So your medical background seeded you with the analness. Is that a word?
I think it's usually referred to as anal retentiveness, but
anal
yes,
retentiveness.
Let's make it
run
the
with
title
analness.
this week.
Yes, the analness to carry over into your other designs. And is that a good or a bad thing?
I think you need people like me, and I think you also need people that are much less restrained, working together.
I.e. more productive, perhaps.
Yeah, exactly.
Right.
I had an intern whose nickname was Hurricane because he was the fastest person I've ever met to get the first 80% of a project done. And destroy the lab in the process. And there was no way for him to go from 80% to 100%. But in the time that I did the 0 to 80, he would do 40.
Wow.
Yep.
That's iteration, folks.
Yeah, no, so you've got to have people like that. You know, you've got to have a whole cross team of people like that to really get a good product to market. It's very rare that one person is very good at the whole lot, you know.
Yeah.
So, not necessarily very good, but, you know, because you can be very good at all the parts, but not necessarily
and
have
speedy
the...
and quality. Yeah,
but not necessarily have the motivation and the, that sort of thing to do them all, so to speak. So, because some people get satisfaction just from doing that hurricane, that 0 to 80% as fast as possible, and guys like you might get satisfaction from doing, the nice, the final 10% really, really well.
And I'm rather proud that everything I've worked on since graduation has made it to market or through regulatory.
That's
nice.
Totally the opposite to my career. Yep. Everything got shit canned. Yes. Not through my fault, that's just the way it, it worked out.
So where else after that? So you,
sure.
So after DECA, you were at some
internal
other
to
places?
DECA, I transitioned to the 2-man RF team and spent a year learning about radios, which was a blast. I transitioned from there to Luminary Micro, which actually halfway through my interview process was bought by Texas Instruments. So I got to work with the Stellaris line, and that was a lot of fun. Little
Doing
M3
what?
Cortexes.
Doing what?
So I was on the engineering marketing team, which means that I developed things like evaluation or demo kits. Specifically, I did an FPGA eval kit. So the Stellaris line has a nice memory port that can hook into other machine interfaces.
That's pretty cool.
Been there, done that.
Yep. And
the world's most expensive demo board, the nano board, the Altium nano board. Oh, goodness. Only $4,000.
Oh, my goodness.
That's what we said, and then i.e. the people on the team said, yeah, except not in such nicer language. But marketing said, oh, yeah, we'll sell 1 million of these. And yeah, okay.
I'll buy $40 worth of one.
Yeah, exactly.
You get a foot stand.
I also did the math library for the Cortex, a fixed point motor control. So how you do fixed point math in that processor, which was way too much assembly code.
Yep. Because it needed to be optimized, obviously.
Yeah. It was meant for embedded motor controls or other control loops. The M3 Cortex has a really beautiful multiply unit, and it also has a really beautiful shifter, but it doesn't have any support
shifters,
for
multipliers. Sorry, we're not making fun of you. We're just nerding out over.
But it doesn't have any floating point support. To hit those timings,
you have to code it all in assembly.
Yeah. We tried to do it in C, but unfortunately we needed to support 7 different compilers, and convincing those different compilers to all emit the same ops was not feasible at the time.
You got to the screw it, I'll do it myself point, huh?
Yep.
Is that 7 different vendor compilers all offering different compilers for your chips?
Exactly, because it was an ARM M3 Cortex, so the ecosystem was very well developed.
ARM, and there's plenty of. I was going to say 7's a lot, for something like the. Texas Instruments Stellaris ones,
right.
But yeah, they're an ARM platform.
Yep.
So, yep, that's tough. And what sort of speed difference did you ultimately see by moving to assembler from C?
It's hard to nail that down in specific ways. We were able to get most of our advanced functions under 100 clock cycles.
Yep.
And if you're going from floating point, then it's up in the multiple thousands.
Right, of course.
And my favorite was that we were able to, on average, beat the C2000 DSP, even though that processor is nominally designed for these algorithms.
Yeah, that's interesting. Okay.
You hear that, Trey?
So you've just wiped out the entire Texas Instruments DSP market because you can do it faster in ARM and assembly.
Oops.
Oops, there goes their entire division collapse. Sell your TI shares now.
We'll have Trey and Eric back on at some point. They could duke it out.
Right.
Instruction by instruction.
I'm ready for it.
Battle of the opcodes.
That's right.
Oh, goodness.
So
what was next? So I got a little bit bored of the assembly code. Had a blast with the team, but I then moved on to National Instruments, where I worked in their educational division. So essentially, I played with Lego robots for 3 years.
Sweet.
That must have been really tough on you, man.
Yeah.
It's got to be.
You get those calluses.
Yeah, the bump size calluses from the Lego bricks.
Yep.
Is that the one that the first uses as well, like the first Robot League or the Lego League rather?
Yeah, exactly. I worked on 2 of the versions of it. The NXT is the one that's been used in first Lego League for the past several years, and then the new one that just came out is the EV3. Which is currently in transition in FLL. So you can, I believe this past year, you could use either of them.
And the EV3 is the one that was I remember hearing about that. That's the Linux-based one or whatever that has Linux on board?
Yep.
Yeah. That's pretty cool. So you were there when they started doing that kind of stuff? Or
Yeah, I did the communication for that device.
Oh, is there like a proprietary bus or what is it? I've never used it.
Just doing the driver support for Wi-Fi and Bluetooth and USB.
Oh, cool. Okay. That's great. So you had to like port Linux and then rewrite drivers and stuff like that, or
sure.
what?
I was on the host side, but my counterpart in Denmark did what you were just talking about.
Did you ever get to go over to the factory?
It was a blast.
You lucky bastard!
It's a scene from The Sorcerer's Apprentice, but you get to touch things. It's fully automated. There's no manual labor in the. No repetitive manual labor in the factory. They have these 6 modules off of the main corridor. Each one has, I think, 100 to 150 injection molding machines just doing their thing.
Oh, man.
And
that's awesome.
Pumping them out. Right.
Yeah.
Wow.
Printing gold.
Really surprising parts for me was that these parts coming out have such a high static electricity charge that when they fall into the bucket, they're repelled back up, so they fall in, bounce off the electric field, slam into the side, discharge, and then they can fall in.
Wow, that's interesting.
I've never seen.
How do they get that charge? Is it from the injection molding process? How does that? What's
I
the
believe
physics?
so, but my
idea?
mechanical engineering is pretty weak.
That's crazy. I just thought of an idea for a new weapon.
Right.
Hold still. I'm gonna injection mold 1,000 Legos near you and then touch you.
Projectile Lego.
That's one. Kerchunk. That's 2.
So is it just the one? There's only one place in the world that they actually make these. There's only the one actual factory, or?
I'm not clear on that one.
Right.
Yeah, I can't answer that question.
Got it. And are these just the standard bricks, or are these all the all the little men and all the little
Everything
characters and all the everything they have these days.
Oh, I'm gonna get the brand name wrong, but they're Polly Pocket clone. Lego's gonna hate me for saying that. They inject all the little accessories and in one shot, and then put it in a bag. And there's a robot that's doing all that and just spitting out these accessory bags. They're also the world's largest tire manufacturer.
Wow. Because
right.
there are many tires, right? Yeah, I think I've heard that statistic before. Yeah,
and
that doesn't count.
Yeah, exactly.
I would pay money just to watch that machine go all day, because it's after its injection, there's 5 or 6 post-processing steps. And
oh wow,
yeah, it's insane.
I would assume, because it's just the sheer number of variations, they must have their own in-house mold making.
Definitely, yep.
Things,
for sure, yeah.
Right? Yeah, they wouldn't subcontract that. They'd just do that, and they'd have a whole department just making molds. They'd have 1,000 Oompa Loompas there, just spitting out these titanium molds.
SolidWorks Oompa Loompas.
I think that's actually their primary job there. So the humans will make the molds, clean the molds, and set up and tear down. But then the machines will run for weeks without intervention.
Make the bricks. Because you've got experience with this, which with your product, which we'll get into in injection molding side of things.
Yep.
So what sort of mold material do you have to make to churn out 1 million Lego bricks without the mold, failing?
ABS.
I can't remember if it's an ABS or an ABS polycarb blend, but it's somewhere in there.
Really?
I always remember people telling me about
ABS mold. I thought it was like
no.
The mold,
some sort of
that's
metal.
hardened steel.
Oh yeah. That's what I'm talking about. Yes, the mold itself.
So you're saying like 1 million shot mold, though, Dave?
Yeah.
That's what you're saying. Well, they probably just turn over molds more often than. I mean, you can do million shot molds, can't you, Eric? I mean, like that is a possibility. But
you're past my depth of knowledge. But yeah, when I did take a DFM course, a design for manufacture course, and the part on injection molding, they would have stats. So like if you're running really cheap molds, you can have this draft angle and a bunch of guidelines. If you're expensive, you can do this. And then the last category was if you're Lego, then you can do these things that are impossible for anyone else.
Apple. Yeah, Apple was the other one I always heard for like the super finish and stuff like that.
You got it. Yeah.
No ejector
because it's
pin
all
marks.
about the smoothness of finish and the and the wear angles and how sharp the angles can get and all that sort of stuff, right?
Yeah, I mean, those Lego pieces aren't going to stab themselves into people's feet. They have to make them sharp for when they're sitting on the floor.
Yeah, they do have the post-processing step where there's the angle grinder to make sure that they have that nice get-into-your-foot edge on them.
Oh, yeah.
Right.
Yeah. The Yelp angle.
And are these like visually inspected, or does someone just do a once in a million brick batch inspection, or how does it?
I didn't see any human inspection.
Right.
So I'm not sure if they're doing an automated optical or if they're doing what their quality control process is there.
Okay, interesting. Well,
remember, he didn't work for Lego, Dave.
No, I know, but he's visited the factory.
But he's been there, I know.
He's the only one we know who's been to the factory. We have to extract all the information
That's right. That's right. He's seen the magic happen.
Oh, goodness.
We need you to work for them again, Eric. We need you to get back in there.
You mean I have to play with toys again?
Yeah.
Sorry, all right, man. I'm on it.
Okay.
So why did you leave your job making toys?
So the story is that my undergrad advisor sent an email to a mailing list that I was on, and I replied with a sarcastic response and accidentally hit reply all. And as a result of that, I got a job as an adjunct here at Olin.
Oops.
Yeah.
And they say snarkiness doesn't pay.
It paid off in spades. I'm really loving it here. And I realized that teaching is what I want to do.
Nice.
Excellent. Someone has to do it. So thank you very much on behalf of us all.
Someone has to do it. That's
well,
right, Dave.
I almost became a teacher once. And
you are a teacher, though. You're just a teacher in a different medium.
Oh, kind of, yeah. But not with the the direct feedback of people in the class. It's totally different. I put my material out there, and that's it. right? Take it
people,
or leave
ew.
it. You know, I've got to deal with humans, you know, and I don't like I love it when people are as enthusiastic as I am, but I know that, you know, from my experience being a student, that most people aren't as enthusiastic as I am, and I can't stand that.
Yeah.
So,
well, Eric, how many? I mean, so you're not 10 plus years out of school or anything. So what is your reaction to that kind of stuff? Do you see people that are you know, kind of ho hum about the field, or is it pretty decently because you know they're self-selecting going to Olin?
So it depends on what you're teaching. So core classes, you'll have a mixture of students that are super excited about it, and some students just need to get that particular requirement out of the way. The seminars, they're all psyched about it because they don't have to be there. They're just there because they think it's interesting.
Yep.
I teach a lot of computer architecture, and that one's a blast because even if you don't want to be a computer architect, there's enough to learn in that field that is confusing and interesting that I can usually keep their attention.
Yeah.
But there's always a couple playing cookie clicker or whatever the latest Flash game of the month is.
Angry Birds and all that sort of
stuff.
Yeah. Right.
Yeah, I always wonder about that. Like, I was just before the laptop time. Like, some people had laptops, but I would never have survived if I would have a laptop. You know, like even if I was supposed to be doing spice simulations or something fun in class, you know, like that. I don't know.
Well,
I don't think I would have survived.
Back when I was a boy, we did have laptops, but like there was no internet. Right, the internet didn't exist, right? So it was there goes that huge distraction right there. So the laptop was just a tool to, you know, write and actually design stuff on. That's it. Which
plus you probably threw out your back trying to get it into the classroom.
Oh yeah, it was a I took my old IBM L40SX 386 SX notebook, you know, and yep,
that was the one that you could only go through double doors.
Yeah, right. I'll pay that. All right. Oh goodness.
So is this like so the other thing I wonder about with like the teaching side of things, and then we can get into the moosh, is this kind of like because it's a newer school as well, you're kind of designing even the core curriculum stuff from scratch? I mean, do you have a lot of license on that stuff, or how does that go? So
with the seminars, I just have carte blanche, and that's exciting and terrifying at the same time.
Yeah.
That's where the magic happens.
With the more core classes, it's not necessarily just do whatever you feel like at the time, but I can rewrite my lectures on a moment's notice, and especially the first year that I was teaching, a student would ask a question. I'd say, well, dang it, now I have to go and rewrite the next 2 weeks' lectures because that was a really cool question.
That was a brilliant question. Yeah, you bastard. Yeah. Thanks. No, but that's how it gets refined, you know, and yeah.
Yeah, well, and I think my gripe was always with professors that were like, you know, tenured, third year kind of stuff, and they're just reading their slides they did from 30 years ago.
Yeah.
So,
yep.
As long as you're not doing that, usually I think you're winning, you know, if you're engaged.
Heck, I had, you know, I'd point out something and they'd actually tell you to shut up. You know,
really?
Like, yeah, that's how bad, don't question, shut up. You know, and yeah, so you're flipping the bird.
I'm sure they went over well with Dave. I'm sure that's
that went down real well. You know, I'm sorry, but you're wrong. You've drawn that wrong, you know. Yeah.
Yeah, I don't
anyway,
think I can get
let's
away
not
with
go
that.
Boy.
So let's get into it. So the Mooshimeter. First off, I kept repeating at the beginning of the episode. Does it derive from mushi mushi or moshi moshi?
No. So moshi moshi.
I don't even know what that is.
It's a Japanese greeting, and
a telephone.
So if you pick up the phone, moshi moshi. No, it's actually from Zen Buddhism. This will sound a little weird, but the phrase "mushin no shin" is direct translation "heartless" or director translation "heart without heart." And The
I'm going to
cultural
call my product Heartless.
Yeah, the cultural translation is to do what you need to do without overthinking it.
Like picking a name.
Ouch! Ouch!
I think I made that joke when you and I were having beers last time, so I think it's fair to say it online. Come on, man.
Yeah, I think you owe me another beer then.
Yeah, I think I probably do. Yeah.
But yeah, it's the don't get too wrapped up in the biases and the things that get in the way.
Yeah.
And it was funny at the time, and I enjoyed it. So,
which
great.
is ironic because you come from the anal retentive medical background, and you're fussing over all the super duper fine details of this thing.
Yeah,
that's right. Yeah,
I think also I grew up in Tokyo, so the concept is closer in my head, and my partner is half Korean, so maybe to our ears it has a different ring than to a more Western ear.
Yeah,
there you go. Yeah. Well, doesn't it mean something bad in German too?
Oh,
I think I saw that on the EEV blog forum.
Yeah, maybe that's not fit for air, but yes, it is something that you would more likely read on the stall of a bathroom in Germany than you would know.
Right.
We'll let listeners go look that one up on their own.
Yeah.
That is an unfortunate happenstance.
Oops.
Oh, good.
Yeah, these things happen.
I mean, it's not quite the Nova that doesn't go, but it's close.
Oh, yeah, Nova, yeah.
Or the Prada, which is wanker in Spanish or something, is it?
Oh, really?
Yeah.
I don't know. Like, I wonder about that. Like, especially like 30, 40 years ago. I mean, there was a lot less not worldliness, but just internationalism, right? You didn't have to worry about that stuff. And these days, it's like,
we can look that up on Google. Yeah, we can whack it into Google Translate. Oh, it means wanker? Great. Hey, I'm going to make fun of you.
I mean, maybe. I mean, like, I don't think I would have thought of that to look that up, and especially across languages, because you're not going to get results in a different.
And language, the German word is not spelled the same way, so it didn't pop in any of those.
Okay.
Just sounds like it.
It's just not going to work. So tell us how the Mooshimeter and your mushy company came about. Sorry.
Sure. So both James and I have experience with mobile robots. So mine is from the educational space with FRC. And I spent a lot of time chasing robots or riding them and trying to take these measurements. Because as soon as you take a mobile robot up off the carpet and put it on blocks, it's a totally different beast. James had been working at Boston Dynamics on Petman and all those really super high-end mobile robots. Like
those evil-looking ones.
Yeah.
They're now owned by Google.
Yeah. They're beautiful and terrifying all at the same time.
Right.
And we came to the conclusion that you can't take a measurement on a bench and get the same information that you would if you could measure it in situ. Yep. And the biggest barrier to that was the human. So what we wanted to do was put a little bit of an air gap between you and the measurement you're taking.
Uh-huh.
We had been working on some other Bluetooth Low Energy devices, and it seemed to be a natural fit.
So did you originally start out by going, we'll make a product out of this? Or did you just go, we just hack something together for our own use?
It was the second. We hacked it together and then realized that it would be very useful.
Right.
Yeah.
As most good designs come out, because if you go into it thinking, I'm going, this is a product idea because I don't care about that. This is what I'm going to do, and then usually, the engineering tends to fail.
Well, you heard it here first. Dave thinks it's a good idea.
That's right, and it's a headless unit.
No, I've never said it's not a good idea. I've said that they're not a replacement. Wireless, these phone-connected multimeters are not a replacement for a regular multimeter, as a lot of people think they are. And he agrees. There you go, folks. Thank you.
Right, but may I interest you in my brand new hammer? It has a rotating head so that when you hammer in screws, it's even more effective. No, it's yet another tool in your toolbox, and as engineers, we need to select the right tool for the right job.
Yeah. No, totally. Yeah, if you would need to measure something in situ and you can't have wires go into it, it's the tool to use. You can sort of put your multimeter on there in data logging mode and then set it and go, and then it sort of, logs the data, and then you can take it off later. But, it's not quite as versatile as a phone-connected one. Totally.
Right.
I got nothing against these at all. I think they're great.
Well, we see this too with so that Fluke one came out with that headless unit.
Yeah.
And there's been one or two others, right? But those are definitely like
proper
more traditional
multimeters.
multimeters versus. So yours has like actual overtime tracking type stuff, right?
Yeah, it has support for an SD card.
Yep. Data logging. Yep.
But I meant like tracking like on the smartphone screen, like over time you can do.
Oh, sure, the trend
time-based
mode.
measurement.
Yeah, so we can. If you rotate your phone, it detects that and puts it into a trending graph.
Okay.
Yep.
And then that can either give high frequency burst, so at up to 4 to 8 kilosample through a 1 kilohertz analog front end, or updating a couple times a second so that you can see slower trends.
Got it.
Yeah, and so I remember you had this in your intro video too. You had this in like the hood, under the hood of a car, kind of monitoring something. You could monitor from the other side of the firewall as you start it up. I remember that was one of the examples. Obviously, you said robots. What other stuff, like isolated type stuff as well?
Yeah. What I really like is that it's a 2-channel, which allows you to start taking a look at some of the relationships.
It's voltage and current, right? It's not 2 voltage channels.
So it depends. There's 3 inputs. One of them is a internal current shunt. One of them is a up to 600 volts category 3, and the third one is either resistance or diode drop or precision voltage input. So that thing caps out, I think, 1.2 volts maximum input.
Got it. So if you want anything over a couple of volts, you need to use the 600 volt input.
Exactly.
Right, got it.
But one of my favorite things is to use that with external current shunt. So if you want to measure something like power factor or other unitless measures where the gain accuracy of just using a piece of copper doesn't matter, it's a really handy way to do that.
Right.
So we can enable any 2 of those 3 channels, and from that, start taking a look at the relationships between them.
Cool.
One of the difficult things in FRC is to track battery health, and so from this you can pull out the VI curve of your battery pretty fast, and dead cells just light up like a Christmas tree on that graph.
Yep.
Like, you mean as they go over that final the dive at the end? You mean, or
you see a discontinuity in the VI curve that indicates one of the cells is dying or dead.
Huh. That's cool. So can you gang these things up too? Like, can you have multi units going into one like phone, or do you have to have pair them up separately?
Sure. There's the marketing response to that is that yes, but the engineering response to that is not yet. There's nothing inherent to the protocol that prevents that. But as of right now, we have not put the development effort into enabling that.
Because that was going to be my question. When you're making something like this, you may as well make it multi-channel.
Yeah. But time and money, blah blah blah. Yeah, we get it.
Right.
It's definitely on the list.
The dreaded list.
Yeah.
Yes.
We know how lists go.
Yeah.
Now I've got a project coming up that uses Bluetooth LE, or I want to use Bluetooth LE. Do you have any numbers on how low you can actually go in terms of transmit power? Transmit current. How much power that these things take during transmit? What's the absolute lowest you can get? Because my project is super duper ultra low power, yet I want to transmit some data at like 1 second bursts.
Okay. The number that I usually ballpark with is about 100 microwatts average draw if you're waking up and bursting every 5 to 10 seconds.
Right. I'm interested in peak current of the transmitter, not average.
I don't have those numbers on hand, but I'd be happy to take a look for you if you'd like.
Cool. But how can you measure them? Wirelessly.
Yeah, that's our new multi-channel approach. We'll have Mooshimeters measuring Mooshimeters.
It's Mooshimeters all the way down.
Yeah, that's it. I love it.
So let's talk a little bit about the logistical side. I mean, so you crowdfunded this thing. What was that process like, and kind of taking us through? I guess kind of taking us through your blog posts. You have a lot of good blog posts here.
Oh, thank you.
But what's been the journey?
So marketing is not something that comes to me naturally, and it's not something that comes to James naturally. So fortunately, I was able to pull on several mentors that I've picked up over the years, and they slapped a little bit of sense into me. We never went for too much of a glitzy glamour approach, and instead just wanted the product to speak for itself. So if you look at our video, I don't know if there's any human faces in it except for maybe the last little montage.
Right. And you went through Dragon, right?
Yes.
Why is that? Why didn't you just do your own thing?
So I think what Dragon provided for us was mentorship in the areas that we didn't have experience or a background in. So like marketing, like that whole crowdfunding aspect, how do you engage people? And it was really valuable to be able to talk to their team and to pull from their experience.
So how does that work? Do you guys pitch to them and they...
Yeah, it works almost identically to Kickstarter, where you send them a proposal, and the difference is that Dragon will do more of a technical design review. So for them to put it on their website, we had to have functioning prototypes, and we had to have manufacturing quotes from contract manufacturers.
Wow.
And,
okay. Yeah, so they really vet it, whereas the other crowdfunding sites don't do anything.
Indiegogo definitely checks to make sure, you filled out every field, I'm sure.
And that your email address is valid. Yeah. But no, if you look at the crowdfunding threshold that we set, what that is the result of my favorite thing is a spreadsheet. Is a spreadsheet calculation of what the legit break-even point would be. Rounded up, and there's a little bit of fudge in there for potential things going wrong. But we had to fully plot out everything before they'd give the green light.
That's awesome.
So it goes on their platform, right? It doesn't go on Kickstarter. It goes on through their own platform. Yeah,
and from there it works functionally like a Kickstarter type setup.
Right, yeah, it works functionally like it. But how do you get that Kickstarter hype? Do you think this thing might have been more successful if it went on Kickstarter, or
I ask myself that every once in a while, and I don't know.
Right. Yeah, because you just haven't tried it, right?
So Kickstarter definitely has the advantage in just raw eyeballs.
It's an instant market, kind of. Well, not for everything, but it's...
No, but yeah, I mean, you've talked about this too, Dave. It's not necessarily... you have to bring a lot of your own eyeballs, but I think then it has that kind of little bit of buzz with it too, Yeah,
exactly. Because there's nerds like us, just, all we do is sit there, look through the Kickstarter. Oh, what's the latest technical project on Kickstarter? Oh, that looks cool. I'm going to back that. So you get those extra eyeballs. Just
but I don't think the data backs that though, Dave. That's what I'm saying. Like I think that what it has is when someone sends you a link and they say, oh, it's a Kickstarter. It's like, oh, okay, I'll go check this out. You might be more likely to click it.
Whereas if you go, oh, this is a Dragon innovation, people go, oh, what's that?
Right. Unless you already know what it is.
Yeah, exactly. Which we do, but most people don't. So
right. I was surprised that. So I had thought when I saw your campaign and I talked to you about this, I thought that being part of the Dragon crowdfunding thing meant that also they took you on as like a manufacturing type of.
Yeah, that's
group.
what I thought.
Sure. So Dragon offers both services, but they're not necessarily locked together. So you can take advantage of either one or both.
So do you choose that up front, or do you choose it after and go, oh, no, I can't get this manufactured. I have no idea what I'm doing. Please do it for me.
Either option is available, but we knew up front that we were going our own route.
Okay.
Oh, okay.
Yep.
That's cool.
And has that been a pain in the arse? You'd never do it again, or? It's okay. You
First,
can say
I
yes.
agree with the first part of your sentence. I disagree with your second. So yeah, it is a pain. Would I do it again? Absolutely. It's a blast.
Absolutely, yeah. Yeah, we're a glutton for punishment, nerds.
They never learn. They never learn.
I really
Hardware
like talking
people.
to manufacturing engineers and getting their insights on how they actually make the product.
So what's been the trickiest part about making this? Is it compliance? Is it injection molding? Is it
definitely
production
compliance.
testing? What is it?
Definitely compliance.
Right.
It's the difficult part of compliance is that any time that they find a need for a design change, it is a schedule hit, and it's an expensive schedule hit.
How much are we talking about?
So they don't charge any additional money. It's that your schedule is now paused until you can unpause it, which means that if when you're doing your prototyping, you're used to saying, I can do this on a 2-week turn time. Now it's, how can I possibly get this here before I go home for dinner? Type emergency racing.
Did you ever consider just not doing any compliance testing on it? Safety testing, all that sort of
no.
thing.
Do you like being sued, Eric? Do you like lawyers?
I'm not a big fan of being sued, although I've never tried it.
You won't know until you try it.
I've never tried it, so maybe don't knock it.
You do live in America, so...
Yeah. So one of the surprising things for me was seeing how little testing was required for the United States. The FCC testing was just take a look at the emissions, kind of glance a little bit about immunity, and zap it with the ESD gun at was it 4 kV or 2 kV? It was something hilariously low.
And it either works or it doesn't. If it works, congratulations, you pass. If it doesn't, well, respin it.
And you're good to go. Now, we had promised our backers from day one that we were going to be 61010-1 and 61010-2-.
Can you explain those standards for those out there?
So the 61010 standard generally covers product safety for a bunch of different categories of devices. And then the -2-something standard refers to specific types of devices. So, for example, multimeters are covered either by -030 or by, I think it's -032 and 033.
And these come down to the CAT ratings that you see on multimeters.
Yeah.
Right.
So
what one is yours rated? What
we're rating for category 3, 600 volts.
600 volt Cat 3. Okay. Yep.
So does that mean you put 600 volts of working voltage on the actual case, and then it has to not leak through, or how does that work?
It's way harder than that. What it means is that it needs to be safe for operation in a 600 volt circuit when something goes wrong.
I.e., a huge surge on the line comes through.
Yes.
An 8 kilovolt surge for X microseconds,
Yeah, and that was actually the easy part. So I think is it 6 kV or 8 kV for Cat 3 600?
No, it's at least 6. It's at least 6. Yeah.
And the spec is, I think it's a 1.2/50 pulse.
Yep.
And we can handle that at DC. Yeah. You can just
and it's about the energy of the pulse. It's not about just 6 kV static discharge test. It's a real thumping.
Area under the curve kind of thing, or what?
If you've seen my video where I use Doug's machine to blow up a multimeter, it explodes. That's the kind of machines that they use to. It's it can be a very destructive test. So
yeah. And that one was
and it has to fail safe, right? That is the key.
So it fail safe in a different way than medical devices. In a medical device, when it fails, you typically need to warn the user, which means that a multimeter can fail safe by carbonizing internal to its case. So rapid disassembly, as long as it doesn't hurt the patient or hurt the user.
Exactly, as long as it doesn't physically explode and blow someone's hand off.
Right.
Yeah.
But if you're making a medical device, it has to say, excuse me, you should probably go and take care of this now. Sorry, and have a good day.
Right. How polite.
The safety testing that we had a difficulty, though, was with the dielectric withstand test. So the test you were describing is impulse into the device. So that's across common to voltage.
That's right.
And we have I think it's 10 or 20 mega ohms sticking in the way, and it's this big ass resistor. So that's fine.
Yep.
But what they also tested was 5400 volts AC RMS. So that's 7600 volts peak, somewhere in that range, across the housing.
Yep.
Yeah, that's the test I was thinking of.
Yeah. So what they do is disassemble your device, put it in a sauna.
Stick a probe in?
They put it in a sauna for 48 hours. So it's 93% relative humidity at 42 Celsius, 43 Celsius. Yep. 48 hours, reassemble it, and then wrap it in aluminum foil and blast the hell out of the thing. 5400 volts. And that one was a bit difficult because we had attempted to expose the SD card to the user.
Yes.
Yeah.
That's the killer right there.
And when you did the math, we had margin, but when you test it, we were right on the edge. So you have to survive that for 5 seconds. We survived it for 2.5 after degradation from previous testing. And, we made the decision that we could try a few more times, but I just want to make absolutely sure that we're going to not be in any form of danger to the user. And so we had to seal that up.
Did you recess it in further, put a rubber boot over the SD card or something like that, or what?
So we recessed it as far as it can go, but you still need to access it. So if it was recessed further, it wouldn't have been accessible anymore. And then the interesting part about the rubber boot is that what they'll do is put it in the least happy configuration that it can be that doesn't require using a tool.
Yeah, it's okay.
So if you have a boot,
so it's like idiot testing, basically.
Say it again.
It's like idiot testing, like they intentionally do it wrong.
It's sociopath testing. So an idiot will just poke at it, but a sociopath will pry it open and wedge something in there and attach his tongue to it and
bubble gum. Yeah.
Oh, that's brilliant.
So yeah,
we have to add
flappy.
that word to the show title, Chris. Sociopath.
Okay.
Sociopath
something.
Testing.
Yep.
And that's why you see a lot of battery compartments are now requiring either using a quarter, like a coin to open it.
To open them, yeah.
That's considered a tool in toys. So I know the Lego brick, it requires 2 levers to open. And for that particular safety standard, that puts it in a new category because it's no longer reasonable for the user to open that during normal operation.
Huh.
But there wasn't a way to partially seal that wouldn't be breached during test.
So you had to actually change the mold then, or what?
Yeah. Fortunately, it was just adding plastic, so that it was a pretty quick remachining.
Oh, okay. So it's cheap to add like a little protrusion to the outside of a mold?
Yep. It's the molding process is a negative process, which means that to add plastic, you remove steel.
Just put it back in the milling machine.
Yep. Right. Got it.
Yeah, it's bad when you have to remove plastic, right? Is that the right way?
Yeah,
because then you have to weld.
Right. Yeah, so at that point
weld and redo it.
Yeah, you have to attach some new insert to it somehow, and welding is one of the common ways to do that.
So how much do these molds cost for something like this? For people who are thinking about having a reasonable looking product like this, in its own custom case?
Depends wildly on where you're going, but stateside about 20 grand, in Shenzhen about 5 grand.
Right, and how long a lead time?
Well, our compliance testing made that completely irrelevant, but
right, yeah,
it was just a couple weeks. When we did the full Gantt, it barely impacted anything.
And what kind of mold did you get for what sort of volume?
So we left that in the capable hands of our contract manufacturer. It's a steel mold, but I can't remember which particular grade steel they chose to use for that.
Okay.
But it should be good for maybe 10 to 20,000 shots.
Right, and because you only got basically 1,000 backers, so how many of these did you anticipate selling back when
So we manufactured twice as many.
Okay, of course you would, yep.
That's smart.
But did you have any ballpark when you started out, like, we think we can sell 10,000 of these, or we think we can sell
Sure. So the way we approached that was through our break-even analysis. So we which might be putting the cart ahead of the horse, but we calculated the minimum number of backers that we would need to be able to make this a viable product launch, and went from there.
Of course, that's an absolute minimum you have to do as a
yeah. And then we figured out what the step function is for what our COGS cost will be compared to the number of units produced. So there's discontinuities in that function, and we had to talk to our contract manufacturers to find where those were. We were aiming in this 1,000 unit range, but I think neither of us wanted to jinx it, so we didn't admit it.
Right, okay. At what sort of volume do your costs come down dramatically in this thing? Is there any sort of volume that you can see, or is it just pretty much whether it's 500 or 5,000, it's really going to cost the same?
Sure. So the absolute worst number of things to make is 1,000.
Right, why?
So it's that transition point where faster prototype type manufacturing techniques are more cost advantageous, and it's a little bit before the super high volume techniques come into play.
As in the moldings and the...
Yeah, well, you can still do molding, but it matters what type of molds you do.
Okay.
So 5,000 is where things are looking pretty good, and once you go above 5,000, and I'm super hyper generalizing here, so I apologize for that.
Yeah, of course, yeah.
But 5,000 is that, like, the difference between 5,000 and 10,000 is okay, not going to change your overall strategy too much.
Yep.
But the difference between 2,500,
1 and 5,
yeah, 1 and 5 is gargantuan.
Got it.
We should also mention too, for people that haven't seen this before, how much is it? So, what was what did people pay as backers, and what's the retail going to be?
Sure. So during the campaign, we had two prices up. For students, it was about $80, and for non-students, it was $100. And we chose to do that in lieu of like an early bird type special. There was a little bit of early bird, but most of that discount came in the form of student discount.
I'm not a fan of this early bird special thing. I think you should pay more to get it early. But it's all part of the psychology of getting people to back your project early.
Yeah,
you know, it's
a
like,
momentum thing.
I know. It's like, yeah, we've talked about this before, haven't we?
Well, I'll be happy to add the Dave category for funding, and just tell me how much more you want to pay, and I will gladly.
The Dave adder.
Yeah.
Well, like I don't like the idea of them paying less and then you shipping them early. Like, if you want me to ship it to you early, I think you should pay more.
Oh,
you know,
I see.
It's one of those. Yeah, that's kind of where I'm coming from there. So,
Yeah.
so
like
my campaigns, I will okay, if you want to be the first batch, then you pay a little bit more. You know, otherwise you go into the regular batch. I don't care if you backed it first. Or
Okay.
not, you know.
If only every crowdfunded campaign started with 150,000 YouTube subscribers, I'm sure that it would work out.
I know, it's
just
probably,
peachy, Dave.
Yeah, I know. 170 or 180 now. Thank you very much.
Oh yeah, sure. Okay, yeah, right.
I think we're up to 80 now ourselves. Not 1,000, just 80.
Just 80. Nice. You got to start somewhere.
Right.
That's good.
And did you find that it cost about what you expected, or did you run over budget, or you ballsed it in and you had plenty of money left over?
So COGS landed pretty much where we were expecting.
Cost of goods sold.
Yeah, sorry, cost of goods sold. So what we paid to make the device, I think we were within 10% of our initial projection.
That's very, very impressive. Yep.
Yeah, you ship enough designs through the process and you get better at it. But it was also that we were very, very hesitant to expand features and feature creep ourselves into oblivion after our original design. The testing was a little bit more expensive, but specifically in the, oh my God, overnight, get me the replacement right now because we have backers breathing down our backs. And,
right.
And,
see, this is where you've got to learn to ignore those pesky backers. That's what the best crowdfunding campaigns do. They just ignore their pesky backers.
Or just take the money and run. One of the two, you know. It's just
we'll deliver eventually.
Yes,
that's right.
We're trying to form a business here. So, was that your intent? Did you want to start like a business, form a company, or did you just want to do a cool product?
To me, it was the product. I've always angled my career towards the thing that I'm doing rather than the
And we like that here on the Amp Hour, don't we, Chris?
We do, yeah.
Oh, good. I was didn't know if I told you the right answer.
No, you did.
He was ready to switch over to the other one right away.
He was.
Like on a dime.
Eric, we don't like that here on the Amp Hour.
Okay, then that is not what I think at all. I was excited to get this type of device out and see how users interact with it, see what type of new use cases it would generate. One of the really cool parts about running the campaign was getting emails from various potential backers or from various backers that
it's fun.
Said, "Oh, can you do this with it?" And just sit there for 5 minutes and say, "Oh my God, you can do that with this." We never thought of that. So yeah, I'm particularly excited about the product and what that'll enable.
Unfortunately, you're probably going to leave to do your teaching thing. You're probably not going to have much to do with this anymore, or how's that working?
So I will be, hopefully, knock on wood, going to grad school in the fall. So if any of your listeners want to be my advisor, that would be fantastic. Just skip the whole application process.
Graduate in what?
I'm particularly interested in low power wireless and distributed sensing.
Right, so you're going to go get a master's or a PhD?
PhD, because my goal is to be able to teach.
Right, and you've got to have a PhD to teach, don't you? I'm not sure how that
works. At top schools, usually, and if you want to do research too, and stuff like that. Okay.
Yeah.
Yep. You signed yourself up for a fun ride, buddy. you thought production was bad.
Take? Yeah. How long you're looking at? There.
So I'm budgeting 5 years, and then I'll hopefully be pleasantly surprised if it is shorter than that.
At where? Where at?
We'll find out.
Oh, right. Oh, okay.
I'm in the
some of the advisor thing too. That
process.
matters.
Right.
Yeah,
okay.
right.
Yes, of course.
So let's talk a little bit about the hardware itself, because we probably should talk about electronics on an electronics show.
Sure.
Is this open source, not open source? I don't actually even know.
This is not open source, but it is open interface.
Okay. So can you tell us what chips are on board, or is that not even that?
Sure. Our BLE platform is the CC2540 by Texas Instruments. Okay. And that's basically just a BLE radio and a 8051 in the same box. And actually the very, very first version used the little 12-bit A to D built into it that has 3 bits effective, just to see if the use case
3 bits effective.
Power monitoring, maybe. Is it on? Yes, no?
I mean, they advertise it as a 9-bit effect. It's cute, but really all we wanted
you're right.
to see was whether or not the use case would be at all valuable. So we just...
A to D built with RF transistors. Switch is really fast.
And then we slapped analog front end from TI in there as well, which is the 1292, which is actually meant for heart rate monitoring.
The 8-channel,
sure, same family, but it has 2 simultaneously sampling A to Ds, and I think you're referring to its sister that has 8 of them.
Oh yeah, that's the one for not EKGs, whatever the body current ECG, the body current monitoring one. That's the one that always has 8. I know.
Yeah.
So it's a 2-channel, 24-bit analog front end.
Yep, with internal 12x PGA.
Oh, right.
Yeah.
Yep.
Those are great.
Yeah.
The only shitty thing is always trying to find those on search sites, is because they always separate out A to Ds from front end chips. And that's annoying.
I don't see why they do that, but
because data. I could talk about that in future shows if we'd like.
And of course you discovered that a 24-bit ADC doesn't actually give you 24 usable bits out.
Sure, of course. We've been pulling in our highest speed settings maybe 18 effective, and nudging a little bit over 19 when we slow down and pay attention a little bit more.
At the full 8K sample rate?
So at 8K, then it's down at 18, and at like
Right.
100 or so, then it's back up to 19 point something.
That's still pretty good, actually.
Yeah.
Well, I come from the seismic industry where that's piss poor.
Yeah.
You know,
You're not doing 8K though, were you? I mean,
we were doing 4K.
oh really? Oh, I didn't
Yeah,
know
we
that.
were doing
But you were also
4K,
probably
but
paying. Yeah.
Oh,
through the nose.
we're paying $200 a chip. Yeah.
Yeah, and it's burning like 10 watts each time. Or, yeah, right?
No, because that was a bastard too, trying to get low power. Anyway, yeah, entirely different market. So
Yeah. What about the power though? So what's the battery life on this thing?
So we're still characterizing to make absolutely certain, but the number that I like to work with is 100 microwatts. So at that point, if all you're doing is waiting for someone to come back and pay attention to it, then you can actually get into the years. But as soon as you start to really crank it, so if you turn on everything and set it to yes, please vary, it gets down into to about a 10-day battery life if it's going continuous.
and it's powered from two AA batteries.
Yep,
is
two
that right?
standard AA batteries.
And I assume you have to boost that up because, well, can you, or do you work straight off it down to like the minimum 1.6 volts?
So the logic runs straight off of that, but we do boost and filter the analog front end just so that it's stable.
Yep.
Yeah. Do you shut off the front end like in order to save power to that, or
yes.
how does that work?
Right.
Yeah, that whole end just shuts right down.
Yeah,
That's
you
cool.
would have to, otherwise you'd be chewing a lot of power in your boost converter.
Yeah, and there's too many linear elements in there to keep them running.
And what voltage for the battery did you get down to? What's your low cutout? Sorry, I need to know about that. I love batteries.
I know, right?
Battery power
For
stuff.
the digital end, I would have to...
No, your entire product, what can the batteries work down to? Like if you're powering it from alkalines, can they work down to 0.8, which is deemed to be the minimum working voltage for a AA alkaline, and then it just falls off like a brick wall after 0.8 volts?
I think our original design before we were boosting left about... it was something up in the 15 to 20% of that, so we were before the 0.8. But
right,
once we
so
added
you're
the boost...
probably a volt or something. You're probably a volt per cell then?
Yeah. But once we added the boost, we're good to drain those straight down.
Right.
So what about so Dave knows a lot about these sense elements. So like what's the range on input currents as well? I guess we can read some of this stuff, but so it can do 10 amps, but that means you're doing are you using like super fancy metal foils like Dave is, or on the microcurrent, or what?
No, it's just a nice what is the technology here so that I don't lie to you by accident. I mean it's well, I will pull up the schematic right now, so I'm definitely not going to lie to you.
And are you doing software cal of the units, or
Yes,
is it, or do
definitely
you
software
build in
calibration.
Right,
Since we have
yeah. So you can use cheap parts
yes.
with low drift, whereas I'm using precision parts. That's why each one of my shunt resistors costs $5.
Oh goodness!
Right? Yeah.
Yeah, I have mixed feelings on calibration techniques, but with this one, because we're going to need to calibrate to hit anyway, then I'm happier with a low drift and fix it in software approach rather than the hit it straight out of the birth canal.
Right.
That is the first time I've ever heard that phrase, but
But Chris likes it. He's going to use it.
I will not be borrowing it. No, sorry. Yeah, I think it's probably good too, because I think about like a bench meter too. You know, you usually those are spec'd for like warm up times and stuff like that, but you know, this thing's going to be who God knows where, right? So there could be a lot of time or temperature variation and stuff like that. So
Yeah.
cool. So what else should we know about this thing? What so are they shipping to producers yet, or?
Sure. So the latest blog post showed the circuit boards in full manufacturing, and so we should be receiving those.
I watched the video as they went through. Yep, the pick and place. And
I love that pick and place machine.
yeah, they're great, aren't they? You can they're just magic.
You just have to make sure that you haven't done any soldering yourself within some safety window. To see that thing go and place dozens of devices per second, and then you do a board in an hour or two.
Yeah,
It's a little
it's
infuriating.
insane.
So
Damn
we're targeting
my feeble human skills.
If only I was a robot.
Yeah.
I'm tired of soldering these QFNs by hand, but you gotta prototype at some point.
Oh goodness.
So no, we're hoping to ship to backers in mid-October. All systems are go. Most of the components are either already in our warehouse or sitting on a customs dock right now. And the main thing we're waiting for right now is the circuit boards, which are in beautiful production.
So is the project late or on time or what?
It's a little late. I think we're slipping 2 months.
Okay.
And
Not bad for crowdfunding, I got to say. I mean,
yeah, I know. Some of them are 2 years. Yeah. So
especially when it's tested. That's another thing we mentioned before the show. Totally. I think the fact that it's crowdfund. I think we set a bar pretty low for crowdfunding projects. No offense to some of them, right? But But yeah, I mean, that is tested and everything. That's impressive to me.
This is
like
compliance. This is full compliance tested, safety tested. I mean, how many crowdfunding campaigns do that? Not many.
Yeah. So then what? People can start buying them or what?
You can pre-order them right now on our website, moosh.im, or as soon as they ship, then we'll convert that pre-order button to an order button, and hopefully we'll be in distributor stock very soon after.
And you're going to sell it yourself, or you're going through a distributor, or what?
A bit of both.
Okay.
Don't want to talk too much about details there until it is officially public, but yeah,
That's cool.
Yeah.
It might be available through Adafruit. So.
Yeah. Me and Eric had talked about how this would be a good platform for something like contextual electronics too, where it's like, good balance of like stuff people have, like a phone or a tablet or something, and then, but also pretty decent accuracy specs, stuff like that, stuff that people can use.
Is it going to be in this sexy see-through case?
Yes, I love that part.
Yeah, it's good, isn't it?
Want to make sure that we stayed well away from Fluke Yellow, so...
You're right, yes. Have you thought about like a little silicon holster for it or something?
Oh, like a Oh, that's interesting.
Like just a little holster so it can grip on, because otherwise with the plastic ass just sliding around, you shove it in your product, you try to measure it, slides around. And...
Sorry, when you said silicon, you meant with oxygen in there as well.
Silicone, like a phone. Those,
Sure.
the
we
phone
have looked
slip
at
on.
It, but right now our volumes don't support that type of housing, and I'm hoping that they will soon grow to the point where they do.
What volume do you need? Because I'm curious to know about that. For something.
It's that we could support it. Like if 1,000 people said tomorrow we want this case, and we will pay for it. Right. That's plenty, but. Right now, we've only had people tell us they want the meter, and they haven't told us they want the housing.
Okay. We want a meter, and we want some double-sided tape, and we'll be fine.
That's it.
So our current mounting methods are zip ties or lanyard loops. It straps down to most things pretty well.
Yeah. Nice.
When Dave said holster, I was thinking like 6-shooter, like cowboy,
right?
Having having 2 Mooshimeters at the side and
draw.
I'm hoping for a bandolier of them.
There you go. Oh, that'd be good. That's some marketing stuff right there. Now endorsed by Chewbacca.
Maybe we should have gotten you as our marketing team.
No, I'm not available. Sorry. But yeah, I think a lot of people in the audience will be interested in trying one of these things out. I think the price is right, especially this is that right price point of like, yeah, I'll try it out, for sure, right?
Yeah.
Why wouldn't I? And so I think a lot of people will be very pleasantly surprised with this.
Oh, thank you.
It does work Android and iPhone, or just one?
Android and iPhone.
Nice. Sweet. Cool, man. Anything else people should know about the Mooshimeter or Mooshim engineering?
I think we've covered it. Thank you.
Cool.
Thank you.
Yeah, people should, like we said, people should definitely check out the blog post. There's a lot of good learnings and pain in there. There's good reading there, so definitely check that out.
So can people stalk you on social media? Of course, when we say social media, we mean Twitter, none of that Facebook.
Yeah, usually.
Right. Yes, but our Twitter account is mostly links back to our blog.
Well, I'm talking about you personally.
Oh, God, no.
They might like you. They've heard you on the Amp Hour. They might love you. They might want to follow you.
Yeah.
I'm too much of an introvert for that.
That's the perfect platform for the introvert. You just tweet and then you go away.
Yeah.
You just don't respond to anyone. You make snarky comments and then people give you job offers. You know what I mean?
There we go. Although I don't think I could do another job right now. I've got 4 on my plate, so I've got to calm it down.
Yeah, well, you can make snarky comments about how you have too much work.
Yes.
Well, thank you very much for joining us, Eric.
Oh, thank you very much. It was a blast.
People should definitely check out Mooshim and buy a Mooshimeter. Thanks again, Eric.
Thank you. Bye-bye.
Catch you later.
Now I put a triangle over here, and it has, 6 dB extra gain.
Well, did I tell you that I have 6 patents on circles that are about half an inch in diameter?
No.